All right, so for number one here, we're just asked to simplify this expression. So we're just adding these, so we just want to combine like terms. So I'm going to start by, we want to put it in standard form. It didn't say that, but we do want to have it in standard form, meaning start with the largest exponent. So the largest exponent here would be the v to the fourth. There's no other v to the fourth, so that doesn't change. All right, next look, let's go down from there. So in descending order, we would have a v cubed, which we have one here, and that's the only one. So it'll be minus v cubed. And let's go to the squared terms. We have a negative 8v squared and a positive 7v squared. We're going to add those together. That'd be negative 1v squared. And then let's go down to the v's. There is no plain old v's, so if you put plus 0v, that's totally fine, not necessary. But then for our constants, we have negative 2 and 8. If we add those together, we'd get a positive 6. So that would be your answer for the first one. Now let's look at number 2. So the first thing I'm going to do for number 2 is I am going to distribute that negative. Seems like a little bit of work, but it's going to ensure that we're more likely to get the right answer. So I'm going to distribute that negative to every single term there. So those all become negative. All right, now, just like the previous one, we're going to combine like terms. So again, we're going to put this into standard form. So start with the largest exponent first. So we have negative 4k, oops, not x, it's k. There we go. So negative 4k to the fourth will be our first term. I look across, I don't see any cubes, so there's not going to be a cubit or a k cube that we would include. Let's go down to the next one, which would be a squared. I see I have a couple of them. I have minus 7k squared and a minus 6k squared. Together, that makes minus 13k squared. And then we only have just a single 2k. And then a negative 8 and a negative 7 together, that makes negative 15. So that'll be your answer for number 2. All right, for 3 and 4, they ask us to find the products. To find the products, you can FOIL these if you want to FOIL these. Remember, we taught this using the box method, so if you want to use the box method, you can do that. When you multiply these together, we would get 7m times 5m, that's 35m squared. This would become a minus 5m. Negative 7 times 7m, that was negative 49m. And negative 7 times negative 1, that's a positive 7. So we would have 35m squared. And then negative 49 and negative 5m, that's negative 54m. And then the plus 7. That'd be your answer. All right, we can do the same thing with the next one. Using the box methods, we'd have 7n plus 1, 8n minus 1. Rather, I'd fix that. Now let's go through and multiply these. So 8n times 7n, that would be 56. Oops. And squared. And then we would multiply 8n times 1, that's just 8n. Negative 7 times 7, that's negative 49n. And negative 7 times 1, that's negative 7. So when you combine like terms, we would have the 56n squared, that would stay the same. But negative 49 plus 8, that's negative 41, so we minus 41n, and then minus 7. So that would be the product of those two factors. All right, these just says factor. You don't have to solve it, but I'll tell you what it would be if you did need to solve it, especially for this first one. But in reality, they just want us to factor. So by the way, too, we're going to change this to be x to the squared, and this just will be plain old x. So if you didn't already do that, if you didn't hear that instruction, or if you missed that, let's just change that to be a squared. So this is a quadratic. All right, so what two numbers multiply together to be negative 32 that add up to be 4? Is that possible? Yes, it is. Because negative 4 times 8 would be negative 32, and negative 4 plus 8 would be 4. Now, this just says factor, so this is all we have to do, and after this one, that's all I'm going to do. But if we had to solve this, we would set each factor equal to 0. We would get x equals 4, and we would get x equals negative 8. But this would be the factored form. Okay, now the next one is a sum of 2 cubes. Now you'll want to hang around or skip to the end of this video. So at the end of the video, I'm going to share the formulas for these. But this one, what cube would give us x cubed? That would be x. And what cubed would give me 125? Well, that would be 5. 5 cubed is 125. So if you look at the formula for a sum of two cubes, my a value is x, my b value is 5. So this just factors to be x plus 5. We'd have x squared. And then we multiply a and b together, and it's going to be minus, so it'll be opposite signs. So we minus 5x. And then it's plus 5 squared, which is 25. That would be the factored form. Technically, it's equal to 0, but all they say is to factor. All right, number 7. This is another quadratic. My a value is 1. So those are the easy ones to factor. So we're looking to see what two numbers multiply together to be negative 12, that add together to be negative 1. And that's going to be a negative 4 and a positive 3. Again, they just ask us to factor. If we wanted to solve that, we could by setting each of those factors equal to 0. We would say x equals 4 and x equals negative 3. We don't have to worry about that one. Number 8, we did not learn about factoring when there's 4 terms. We do that using what we call grouping, but that has not been an emphasis, so we are going to skip number 8. All right, we're going to do a few skipping here just to give you a heads up. We're going to skip 11 and 12, but we're going to do 9 and 10. You need to know how to divide polynomials when it's a simple one like this, a plus 10. Remember, we used one of the methods we used was a synthetic division. We also learned how to do it with the box method. I'm not going to show that, but you can look back in your notes if you prefer that one. I find the least likely to make mistakes. I like the synthetic division. All right, so the first thing we want to remember is, do we have all the terms represented? So we have a 3, 2, 1, and then no a's at all, so that is good. If we had any of them missing, like if we didn't have the 51a here, we'd want to put a 0a in there to hold that position. But all of them are represented, so we don't worry about that. All right, now we're just going to list out the coefficients. 1, 15, 51, and 15 again. And we're going to draw this line, put a basket down there to catch our remainder. Remember the process. Bring down the first term is 1. Negative 10 times 1 is negative 10. When I add these together, 15 plus negative 10, that's 5. Multiply again, negative 10 times 5, that's negative 50. Add those together, that gives me a positive 1. Negative 10 times 1 is negative 10. Add those together, I get 5. So it says if yes, if these are divisible, write the quotient. If no, write the remainder. The remainder here would be 5. So this is not divisible by a plus 10 because you have a remainder of 5. Let's look at the next one. So by the way, at the beginning here, if you're wondering, how'd you get that negative 10? That's the 0 for what we're dividing by. The 0 here would be negative 10. So the 0 for this one is that our 0 would be 3. So we're going to start with that. And then again, look to see, do we have every term represented? So we have 3, 2, 1, and then no k's. So we are good to go. So our coefficients are 1, negative 12, 20, and 21. Draw your line. Put your basket to catch the remainder if there is one. All right, so now let's go through that same process. Bring down the 1. Multiply. 3 times 1 is 3. Negative 12 plus 3 is negative 9. Multiply. 3 times negative 9 is negative 27. Add those together, that gives me negative 7. 3 times negative 7 is negative 21, leaving me with no remainder. So if there is no remainder, we need to write the quotient. The quotient, remember, this is going to stay a constant. That stays negative 7, but then I'm going to put an x in here and an x squared here. So our answer is x squared minus 9x minus 7. That would be the result when we divide by x minus 3. So we call that the quotient. Now for 11 and 12, we did problems like that, I believe, in our notes, but it wasn't an emphasis. It wasn't something that was on the test, and so it's not going to be on the final. So don't worry about doing 11 and 12. All right, 13, end behavior. That's really important to make sure we understand what the end behavior function is going to look like. All we care about for end behavior is the leading term. We get the leading term from the largest exponent. So here's the way I like to do it. Put 2 blanks. The right blank is the right side of the graph. The left blank is the left side of the graph. We start with the right side of the graph. How do we know what to do here on the right side? Look to see if it's positive or negative. If it's negative, the right side of the graph is going to go down. Then remember, if it was positive, the right side would go up. And then to find out what happens on the left side of the graph, we look at the exponent. If the exponent is odd, we go in the opposite direction. If it's even, we go in the same direction. But now, on the test, if this were multiple choice, we're not going to see a bunch of arrows. Those arrows just help us know what's happening on the left and right side of the graph. So what we'll see, though, is something like this. Or we might have, so we might ask you what's happening on both sides or just on one side. We don't know. All right, so if we see something like this, the limit of f of x as x approaches infinity, that's referring to the right side of the graph. Because remember, on the x-axis, the right side of the graph approaches infinity, the left side of the graph approaches negative infinity on the x-axis. So that's what this is referring to. We're on the x-axis. This is referring to the right side of the graph. What's happening on the right side of the graph? The right side of the graph is going down. So it's approaching negative infinity. This is referring to the left side of the graph. What's happening on the left side of the graph? It's going up. It's approaching a positive infinity. That is a terrible infinity symbol. That's a little better. All right. So that's how we would get those answers. Let's look at the next one. So again, start with 2 blanks just to kind of help give us a template to follow. So this I see as positive, so the right side of the graph is going up. I see that this is a even exponent, so it's going to go in the same direction. So the limit on the right side of the graph is going up towards infinity. The limit on the left side of the graph also goes up towards infinity. All right, let's look at number 15. This is the last one we're going to do, actually. No, this is not the last one we're going to do. I'm sorry, I got ahead of myself. But we aren't going to do number 16. So let's look at number 15. So x squared plus x minus 20. We want to find out all the zeros. Okay, the zeros are the x-intercepts. So to do that, we're going to do that by factoring. So what two numbers multiply together to be negative 20 that add together to be 1? Well, that's 5 and negative 4. 5 times negative 4 is negative 24, or negative 20, and 5 plus negative 4 is a positive 1. If I set those equal to 0, I get negative 5 and 4. So those will be my x-intercepts. And the degree is 2, and we have 2 x-intercepts. We found them all. All right. So again, if you're here to look at number 16, you did not have to do number 16. So let's skip that. And let's look at number 17. It didn't say to write it in standard form or factored form, but we want to start by getting this in factored form, and then we're going to multiply them together to get it in standard form. So these are the zeros. So remember, in factored form, whatever the zeros are, so remember we call the zeros C, so the zeros, we just take x minus each of the zeros. We would have, in factored form, it would be x minus 2 times x minus 1 times x minus negative 5 gives us x plus 5. Then we're going to multiply these together. It does not matter what order we multiply them in. I'm just going to multiply these last two together first. So you can use the box method. If you want to use a box method, you can FOIL those. Either way, when you multiply those together, you get x squared plus 4x minus 5. Okay, so again, we're going to multiply these together now. And you can either use the box method. I like the box method for these. I'll just show you that for this one. So we would have x minus 2 here and x squared plus 4x minus 5 there. So when we multiply those together, that would give us x cubed, 4x squared, and negative 5x. Down below, multiply everything by negative 2 now, we get negative 2x squared minus 8x and a positive 10. So when we write this out, we have an x cubed. Our diagonals are oftentimes our like terms. 4x squared minus 2x squared, that's a positive 2x squared. X and a negative 8x, those add together to be negative 13x, then plus 10. So this would be our factored form. And the last answer is what we got in standard form. All right, let's do the same thing for the next one. So these are the factors. I'm sorry, these are the zeros, the x-intercepts. And so we would put it in factored form. So it's just going to be x minus c. So we'd have x minus negative 2, that's x plus 2. X minus 3i, x plus 3i. Now for this one, I am going to show you what happens if you multiply by the conjugate. I want you to remember what happens here. All right, so remember the 3ix and the minus 3ix, those cancel out. And negative 9I squared, remember I squared is the same as negative 1, so that simplifies to be a positive 9, because negative 9 times negative 1 would be a positive 9. So we would have x plus 2 times x squared plus 9. And again, you could use the box method for this. Multiply those together, we get x cubed, 9x, 2x squared, and 18. So our answer would be x cubed, whoops, not in parentheses, x cubed, and then we have a 2x squared. This diagonal does not have like terms, so we're going to keep these separate. So we'd have x cubed plus 2x squared plus 9x plus 18 would be the standard form. And again, this would be, well, actually, technically, this would be the factored form. If they ask you to write it in factored form without any imaginary numbers, that would be factored form, and the other answer would be standard form. All right, so the rest of the review that you might have for me, you can skip. You don't have to do 19 through 22. But I do want to talk about a couple of things that some of these were mentioned in this review. Some of them were similar. But I just want to review some of these formulas. All right, so we've talked about difference of squares. We had an example of like that earlier. So you just want to remember that if we have difference of squares, that factors down to be a plus b, a minus b. And then you want to make sure that you know both the sum of cubes and the difference of cubes. I believe in this review, there was a problem that had a sum of two cubes, but I want you to be familiar with both of them because on the test, it might be a difference of cubes. So you might want to make sure that you have both of these formulas or all three of these formulas in your note sheet. Now, remember, you can't have specific examples on your note sheet, but I want to make sure that we review how multiplicities work. Because this was not covered in the review, but might be something that you want to know for the final. So remember with multiplicities, the zeros, we set each factor equal to 0 and solve it. Now we get a factor every time there's an x. So this x, if I set that equal to 0, I just get x equals 0. With this one, if I set that equal to 0, I would get x equals 3. I'm going to do the work for this one. If I set 2x minus 5 equal to 0 and solve that, I'd add 5 and divide by 2. You get x equals 5 halves. All right, now let's talk about multiplicities. The multiplicities are referring to the exponent for each of those factors. So the x just doesn't have an exponent, so there's one of those. So this has a multiplicity of 1. The x equals 3, that has a degree of 3. So that means that there's 3 of those. And the 5 has a degree of 2, so that means there's 2 of those. And then we got to figure out, well, what does that mean at each of those points? Remember, if it's an odd multiplicity, so this you can put in your notes, the graph is going to pass through the point. If it's an even multiplicity, it bounces off that point. So let's look at each of these. So the multiplicity of 1, that's odd, so it's going to pass through that point where x is 0. Where x is 3, the multiplicity of 3 there, again, that is also odd, so that's also going to pass through that point. And lastly, this one had an even multiplicity as a multiplicity of 2, so this is going to bounce off that x-intercept at 5 halves, or at 2.5. So that's a review of what's going to happen, because you want to make sure you're familiar with multiplicities and what happens with each multiplicity.